There's only one thing left before creating the UI for displaying, creating, and updating notes. We need to finish the application layer by creating a NoteFormBloc. Hello, welcome to ResoCode, where we are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. The NoteFormBloc which we are about to create in this part will be responsible for example, displaying error messages whenever we want to create a note, but the individual fields do not fulfill their expectations of, for example, not being empty. So you can immediately see that we have already done something like this, or at least something similar to this, and that was in the authentication feature of the app in the application layer, where we have already created a sign in form block. So if I sign out, we can see that here also when I try to sign in without providing valid data, the strings which are currently basically empty will be deemed invalid by our validation mechanisms, and this invalid email state will be propagated to the UI, which then will react with this given error message under the text input field, right? And if I enter something correct, matt@gmail.com, now this error message will go away. So the same thing we want to do when it comes to the NoteFormBloc. And since we have already implemented something like this, it is not a bad idea to take a look at what we basically want to redo once again for a different feature. So I have opened up a sign-in form block, which is present here in the auth application feature and layer. And we have a bunch of events here, which are email changed, password changed, and then the actions which can be performed. In the case of the authentication feature, we can register with email and password and sign in with email and password. But of course, in the case of notes, once I sign in with Google, just to be quick, in the case of notes, of course, we are just going to be able to save the note or update the note if it's already created. So let's go ahead and start implementing the NoteFormBloc, right? We're going to go to the application layer, then notes, right click on notes. We're going to create block, new block. Let's give it a name, NoteForm. Hit enter. We do not want to use equatable. And let's rename this block folder to say NoteForm. And let's start off by implementing the events. So as you can see, we want to have the changed events for particular fields changing. In the case of note, the body can change, the color can change, and the to-dos can change. That will be interesting. We're going to come to how we can implement to-dos in just a bit. But for now, let's focus on the simple body and color of the note. So we're going to go to NoteForm event, and we're going to create a freeze union, F union, our handy keyboard shortcut or code snippet, however you want to call it. NoteForm event. Let's import freezed. Let's go to the original file NoteFormBloc.dart, where we are going to create a PTF, so freezed part statement. And actually, since I have the code generation running, since the end of the last part, which I'm recording in a single try. That means that I have already the command running, but you know what you need to run. Of course, you need to run Flutter pub run build run watch delete conflicting outputs. As always, I have it running already, so that's awesome. And for some reason, VS Code has just frozen up on me, which is unfortunate. So let's begin with creating the individual events, right? The first one will be body changed, which body is represented by a string. So let's pass in a string body str, and its name will be body changed. And let's copy it below. It will be for color changed. This will be represented by a color object coming from Dart UI. So let's import that. This will be color changed, of course, with capital C. How else? And the code should get generated, right? Yep, it will be. Cool. And yeah, so these are the simple ones for body changed and color changed. But body and color are only the simple things, the simple fields, although color is not really a field, it's something, some column which is scrollable, or row which is scrollable actually. But we also have sort of a compound primitives which we need to handle. And what am I talking about when I say compound primitives? Well, of course, I'm talking about to-dos, because to-dos are not represented just by a string or just by a integer value, which is a color. To-dos are actually two things combined into one, or actually three things if you think about it. Every to-do is comprised of a text, which it holds, of the done or undone status, and then also every to-do is uniquely represented by an ID. And these things all comprise a to-do. So while when it comes to the body or color, we can just pass in to the event a simple primitive of string or a simple primitive of color, we cannot just pass a string to represent a to-do, because a to-do also needs to have the done status and its ID. So what can we then have the event hold for to-do changed, or actually to-dos changed? Can we have it hold something like list 3? Of course, if I switch to English keyboard, list 3 to-do item. Can we do something like that and import the value objects and also to-do item entity? Well, this is how to-do items are represented inside the Note entity, no doubt about that. If we take a look at Note.Dart, of course, to-dos are a list of 3 items which holds to-do items. But we cannot put this kind of a data type into a NoteForm event. Why is that? Well, if you take a look at the previous events, body changed and color changed, they operate with dumb primitives. String is not validated. It's the job of the block to convert an input string into a validated value object. That's what the application layer does. It connects all of the layers together. In this case, we are connecting the presentation layer, which operates with simple strings, to the domain layer, which is going to validate this simple string into a note body value object, and the value will be returned back to the presentation layer through the block state. Okay, so we need to pass in primitive values. So list 3 is out and to-do item is also out. So can we then pass in a list holding ToDoItem DTOs, right? Can we do that instead? Now we are certainly getting closer to the final destination because list is not validated at all. It can hold any kind of a number of items. So that's nice. And also ToDoItem DTO holds only primitive data. It holds string ID, string name, and Boolean done. The name of the to-do is not validated, and that's what we want, right? That's true, but at the same time, as soon as a to-do item is created in the UI, it's going to be very much beneficial to have the unique ID generated immediately. So basically, whenever I click here, add to do, at this precise moment, as soon as this to-do thing is added to the UI, it's of course represented by a to-do primitive. At this moment of creation, unique ID is generated. So this means that we would highly benefit from a ToDoItem class, which would still have a primitive string name, a primitive bool done, but it would have one and only one value object, and that would be that the ID is going to be represented by unique ID. And we cannot do this when it comes to DTOs, because DTOs should have all of their fields be completely dumb. There should not be any value objects inside DTOs. That's because DTOs are going to be put into Firestore, and all of their data has to be able to be represented by just simple Firestore compatible data types. So what are we going to do? Well, we're going to create a new class. It's going to be called ToDoItem Primitive. And it's not going to live inside the infrastructure layer as DTOs do. This will be actually a part of the presentation layer of the notes feature. So we're actually going to right-click on presentation layer, create a new folder called notes. Inside it, create new folder, NoteForm. Inside it, create a new folder, miscellaneous. And inside this miscellaneous folder, we're going to create a new file called ToDoItem presentation classes. This will hold a bunch of classes for the presentation layer of the notes feature. And we have this deep nesting inside of here because of course we are going to have many more folders inside here. So by the end of this series, this kind of a nesting will not seem as crazy as it does now. But anyway, this is where the ToDoItem primitive data class will live. So let's create a fData class ToDoItem primitive. And as always, by the way, you can get the code from the link in the video description. Okay, let's import Freest. Let's change it to implements because we want this class to have some sort of a custom methods. So we need to do the thing as we are used to. So that means constant constructor, which is going to be private. And now by doing this, we can have custom fields in here. And those we can actually copy from Note DTOs. So it's going to be ID, name, and done. But in addition to these ones, we also want to have the ID be represented by unique ID. And it wouldn't hurt to also provide a part freeze statement like that. Now we are cool. So of course, this is again just creating a bunch of boilerplate, but this is what we need to do in order to be able to use our approach to validating data and having everything be validated at all times. So of course, when we started off this series, I think in the second part, I warned you that you may not need to apply every single principle which I am showing you here. Honestly, in my apps, I really do not use validated value objects. They are something really nice to have, but you can just as well just validate all of your data in the presentation layer in your form fields, and then have just regular strings and booleans passed around and not have any value objects. If you do that, you automatically lose the need to use some classes like these ToDoItem primitives and so on. So really just think about your use case. If you think you need to have validation all across the board, use value objects. If not, ditch them and you are going to be still fine no matter what you do. It's really up to you and up to the confidence level that you want to have in your code being absolutely correct at all times. Now we want to have a quick way to create empty ToDoItem primitives from the UI. So that will create something like this. A to-do which is empty, is uncompleted, and it has a newly generated unique ID. So that's why we're going to create a factory constructor ToDoItem primitive empty, and it's going to return ToDoItem primitive. ID will be a newly generated unique ID, and then name is an empty string and done is false. The next thing we want to have here is just like with DTOs. If we take a look at them, they have the from domain and to domain conversion factory and method. So let's actually copy them here, from domain and to domain, from the ToDoItem DTO, and let's put these into the ToDoItem primitive. Of course, we need to replace all of the occurrences of ToDoItem DTO with the primitive and pass in ToDoItem. We need to import the entity here. Now we're cool. We also need to import the ToDoName value object here. And now the difference between a DTO and our primitive here for the presentation layer is in the fact that the ID is of type unique ID. So to populate our unique ID, we just need to populate it directly with the ID coming from the entity. And when it comes to populating the entity's ID, again, we can just provide a simple ID coming from the primitive because they're both of the unique ID value object type. And it would also not hurt to provide an additional curly brace here so that the brace count matches. And just like that, we have created a ToDoItem primitive for use from within the presentation layer, which is going to be passed in to our NoteForm event. So instead of passing in ToDoItem DTO inside a list, we're going to pass in list ToDoItem primitive. Like that, let's import ToDoItem primitive. Let's change the name of this event to be ToDo's changed. And actually, instead of a list, let's make this thing immutable, just like a string is immutable, by making it into a KT list coming from the KT Dart library. Inside the sign-in form, we have events for signing in or registering the user using our Firebase auth facade. But here we of course just want to have a single event for saving. So we're going to say saved, and the note will be either saved and created anew inside Firestore, or an already existing node will be overwritten inside Firestore, depending on if we are just editing an already existing node or if we are creating a new blank or brand new node. So this will be called saved. Awesome. And talking of editing, how can we create a way to populate our block with some already existing values for the node which we are about to edit, right? Because when we click on a node, we need to have a way to get this quam si plane sig verterem and so on into the block. The same goes for the color for the list of to-dos. So how can we do that? Well, we can do that with yet another event. How surprising. It will be called initialized. And this will take in a node, right? Node. Let's import the node entity initialized. And this would certainly work if we already had non-nullable types in Dart at the time of recording this part. I would just make this nullable, and that would be it, because of course it can also happen that we are not editing a node, but we are creating a new node. In this case, we would want the passed in initial node to be null. But since we do not have non-nullable types, I'm going to use an option, our trusted option type coming from darts. And this will allow us to safely represent some node or none for when we are creating a new node. And let's actually call this parameter initial node option. So that would be it for the events. They seem kind of correct, right? We need to pass in only primitive data types, so that's why we are passing in a string, color, and sort of our own compound primitive of to-do item. Now let's go ahead and implement the NoteForm state. But before we do that, let's go ahead and look at the sign-in form state, which we have created at the beginning of this series. So state of a form, the way we implement them, holds the validated value objects. So in the case of sign-in form, it holds email address and password value objects. Then it holds a boolean telling us whether or not to show error messages already. And as you know, we do not show error messages immediately because, of course, an empty node body is an invalid body, but we do not want to flood our users with bogus error messages. So we wait until the first time that the user tries to save a node to the remote server, remote database, and only after that, actually, only after that, if I make it again failing, we show that it cannot be empty. And now we already auto-validate after the first attempt to save an invalid node, it's auto-validated. Okay, let's delete this node from here. Cool. Then we also want to represent whether or not we are submitting, so that we are going to show this nice progress here. As you could see, for a brief moment, the screen got dimmer. And then also, if something goes wrong, we need to have a way to let the UI know what went wrong, and that is by returning an failure. In the case of sign-in form, we return auth failure. In the case of node form, we are going to, of course, return the node failure. Everything will be very much similar also in the node form state, but instead of representing value objects separately, when it comes to nodes, we actually have a way to represent all of the values collectively, because we, of course, have the node entity. So why not utilize an entity instead of, again, providing just field by field separately by their value objects, right? So let's go ahead into the note form state. We're going to create a new fData class, NoteFormState, which is going to hold named parameters. All of them are going to be required. And the first one will be of the type note, of the entity note. This represents all of the fields validated. Then, just like in the case of sign-in form block, we have a Boolean show error messages. Then bool is saving to show the progress of the operation. And lastly, actually, let me copy it from the sign-in form state because it's quite long. So the failure or success option, the option either, right? This will be a safe failure or success option. And instead of an auth failure, it's going to hold, of course, note failure. So let's import all of the needed types. And that's about it, right? Not quite. We have still one more field to represent inside this state, and that is a Boolean for isEditing. This will tell us inside of the block whether we should create a new node when we are creating a new node, of course, or if we should call the update method on our repository. Because if you remember from the previous parts, our node repository has both create but also update methods. So we need to be able to somehow differentiate between calling each and every one of them. And the isEditing flag is the way we are going to do that from within the node form state. And just like in the case of sign-in form state, we want to be able to quickly whip up an initial state which will hold the empty node and everything will be false or none. So let's create a factory node form state. Initial is going to return node form state, and the node will be node.empty. We have created this empty factory on the node a while back. I don't even remember the part when we did that, but it basically just creates unique ID, which is empty, node body, which is empty, node color, which is the first one, and an empty list of 3. So that's what we are doing here. And then show error messages will be false. isEditing will be false. isSaving will be false. And save failure or success option will be nothing else than none. And just like that, we have implemented the state. So we already have the events and the states of the node form block. So let's go ahead and implement the node form block itself, right? We can remove all of the unneeded imports, which we have unfortunately somehow gotten here. And the initial state will be node form state dot initial. Okay. And then we can implement map event to state. So as always, we are going to say yield each actually, and then map the event, hit Control D or Command D on Mac to select all of the nulls. We're going to provide our block event handler and go to the last event, provide a semicolon and a comma so that everything is just nicely formatted. And now we can implement the initialized body change, color change, to-do change, and saved events. So let's start off with the initialized, shall we? This is something that we do not have in the sign-in form block because over there we are not initializing the form any time. But here it can happen. So what should we do? Well, we are going to yield a state which will be determined by the initial note option passed through the event, through the initialized event. So we're going to say fault, and in the case that the initial note option is none, then we just want to yield an unchanged state. And if you know, yielding an unchanged state in Bloc results in no state change. That's because if we go over to the implementation of Bloc and we search for something like a map event to state or something, or transform events, yeah, over here it says, right, inside transform transitions, if transition next state is equal to the current state, this method returns. So this means that nothing is played out, the new state is not emitted as long as it's equal to the current state. So by yielding current state, we don't do anything. But if the initial note option holds an initial note, then we want to return and yield, therefore, state copy with and populate the state's notes with initial note, and is editing will be also true, because when an initial node is passed in and it is sum, that of course means that we are editing a node like this. When it comes to body changed and color changed, they will be very similar to each other. We just want to yield state.copy with and just copy the field in question with a newly validated value. So in the case of the body being changed, we want to copy note, and we want to set it to be from state dot note dot again copy with, because we are operating within nested freezed data classes. State, NoteForm state, is in itself a data class, but this NoteForm state holds a note, which again is a data class. So we have therefore nested copying here being played out. And in the note, since body changed, we want to copy the body with a newly validated value of type node body and pass in finally the body string coming from the event. And let's also import the node body value object. And as was the case in sign-in form as well, whenever we change a field's value, we want to forget about any kind of a possible previous failure which may have occurred. So we're going to set save failure or success option. And we are, by the way, not getting any IntelliSense because unfortunately copy with is not really a method. As you can see, it's a getter. It returns a callable class, and callable classes, for some reason, they do not have IntelliSense, at least on VS Code as of now. So that's why we are not getting any suggestions, but it's compilable code, only suggestions are not working, unfortunately. So we basically want to set it to none to get rid of any possible previous failure, because of course, as I have explained in the first parts of this series, when a failure happens, not this one, but something like pops up from the bottom, some Firestore failure occurs, for example, and we try anew to write something different and then again save it to Firestore, the previous failure should be gotten rid of. Now for color changed, we can just copy whatever was in body changed, and we are just going to say color is node color e.color, which somehow doesn't work. So that's very much interesting. Why is color not present there? I guess we did not change the event's name. Is that correct? Of course. This should not be body string, but instead a color. And just like that, we can come back to our NoteFormBloc, and now the color accessor on the event will actually compile. An interesting thing is going to happen inside ToDo's changed. That's because over here, we are not really just operating with one single level, so to say, value object, which we need to validate, but instead ToDo's are two separate value objects really. One of them is a list 3. This is the first layer of validation. There can only be 3 ToDo's. And then there is also the ToDoItem entity, which is also validated. So we're going to therefore need to provide a mapping for the list items. You're going to see what I mean in just a bit. So again, let's paste in the code from the body changed event. And here, instead of changing the body, we are going to change the ToDo's. They are going to be list 3. And now we want to pass in a KT list of ToDoItem entities into this list 3's constructor. So how can we do that? Well, the event comes with ToDo's, or it at least should. If it did not come with body string, of course. Honestly, guys, you should have told me while I was writing this code that I am messing my names up, but anyway, so let's change it to ToDo's. So now we are told we can access ToDo's, as we should be able to, and these ToDo's are of type ToDoItem Primitive, but we want to map them to be just ToDoItem entities. And since we want to map them, we're going to use the map function, which grants us a primitive. And we wanted to return a primitive converted to domain. This is the function which we have created at the beginning of this part. It returns domain entities converted from our ToDoItem primitives. So we have initialized body changed, color changed, and ToDo's changed. What's still missing is the saved event handler. As soon as we start handling this event, we want to yield a state.copyWith, indicating that we are currently saving something. So this will show the circular progress indicator in the UI and dim the screen. Is saving is true. And also we again just want to reset the save failure or success option to be none. And then what we want to do here is to check if we can actually proceed with saving data to Firestore. And what do I mean by checking if we can proceed? Well, of course, we do not want to save invalid data to Firestore, but instead, if data is invalid, and because it's being constantly validated by our value objects like NoteBody, NoteColor, and list3 and ToDoItems, we instead want to show a helpful error message to the user in the UI. The user can then correct the errors, the mistakes, like for example, an empty NoteBody is one of such failures which can occur. And once this mistake is corrected by the user, then the saving of the note will pass. So we want to save a note only if it's valid. So we can access state, note, and if you remember a few parts back, we created a failure option getter on our note and the to-do item. And this returns none if there is no failure or some if there is a failure. So if failure is none, which means that, of course, there is no failure, then we want to save the note, which means updating or creating a new note using the repository. Of course, we currently do not have any way of accessing the repository, the note repository from within the block. So let's change that as soon as possible. We need to provide a final fallback, of course, final iNote repository, node repository, and create constructor for final fields. While we are at it, let's also mark this class with injectable so that everything is nicely injected, and also this block will be therefore injectable in itself. And now we can access the node repository from this if statement, and we need to decide whether to update or create a new node. We're going to decide on that by checking state is editing. If we are editing, we are going to say await node repository update because we are editing, and the node which we want to update is located inside state node. Otherwise, if we are not editing, we want to say await node repository create and pass in state.node. These update and create methods both return a future containing an either node failure or unit. And we want to get hold of this either type so that we can provide useful failure information from the Firestore, in this case, to our UI. So we are going to create a variable, mutable one, either node failure unit, let's call it failure or success. We're creating it outside of the if statement so that we can also access it outside of if statement, of course. We're going to set this failure or success variable to be equal to the returned value from our repository calls. And now at the very end of our saved event handler, we are just going to say yield state copy with is saving will be false, show error messages will be true, because as I have demonstrated, we want to start showing error messages after the first press of the save button, like this. Now they're going to be auto-validated, so they are being shown already after the first press of the save button, or also after subsequent presses, of course. And we want to set the save failure or success option to be equal to the failure or success returned by the repository. So we're going to say option off and pass in the failure or success. And we are again using the option off method, which is going to return none if failure or success is null. So this means if the node is invalid, because if something is invalid inside of the node repositories method are not even going to get called because we are inside an if statement. So if something like that happens, of course, the failure or success option will be none, because no actual call to Firestore has even happened in that case. However, if something already happened, if the node is valid and this process failed only because of some issue which is happening with Firestore on the Firestore side, then we want to pass this failure down to the user through the presentation layer. Alright, and that's it for this part, which was quite long because we have implemented our ToDoItem primitive and then also the NoteFormBloc together with its state and events. So I really think that now we are really on a good trajectory to finishing up this app in the next few episodes, because really we have fully implemented the application layer for our notes feature. We already have the actor block for deleting the note. Now we have implemented the form block, and we already have the watcher block for watching and displaying the notes. We already have the domain layer, of course, this was the first one that we implemented. We also have the infrastructure layer containing the DTOs and note repository. So really now it's up to the presentation layer to give this something which the user can touch on the screen. It's still going to be a lot of tough work, but we are getting to the finish line. We can already see it before our eyes. So if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this from this domain-driven design Flutter series and also other tutorials which are going to move you further on your app development journey, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.